Hello, in this video I'm going to solve an example for equiprobable sample spaces. Problems like this, although you're looking for probability of some event, but basically is just counting. You count the number of elements or number of outcomes in the event divided by the number of outcomes in the whole sample space, which should be equiprobable sample space. Let's see what is the question. 12 girls are randomly divided into two teams to play volleyball. That is, these two teams will play against each other. What is the probability that Anne and Alice, two of the 12 girls, are not in the same team? So, well, if we list all the possible ways that we can form these two teams, that is going to be an equiprobable sample space. And we have to find what is n of s, which is number of ways that we can form two teams of 6 out of 12 girls. This is very related to the labeling problem. So here, if I have team A and team B, then the number of ways I can do that is that, well, I choose 6 of the girls for team A and the rest to team B. That would be the number of ways we can do this if one of the teams is distinct than the other one. It has a different name if they are going to have different color than the other one. But here we don't have anything that makes distinction between these two teams. So this team A and B is something that I made to be able to use this formula. So the number of ways we can do this is this, but now I overcounted. Team A, B doesn't exist. There are two teams. So if I change the teams and put team A as team B and team B as team A, then I'm not changing two teams. What I mean is that naming team A, B created overcounting. So we counted each situation, those two teams, once as team AB and then team AB like this. So that means that to be able to get exact number of ways we can form two teams of 6, I have to divide that number by 2 factors, the number of ways I can permute this team A and team B. So that's n of s. How about n of e? N of e is the number of ways we form two teams such that Anne and Alice are in different teams. So they are not in the same team. Well, that means what? That means that we have a team labeled by Alice, so Alice's team and Anne's team. Well, then we have labels. We have a team, we can call it Alice's team, Anne's team. We have two distinct labels, but how many members each team has? We already have Anne in this team and Alice in this team. So the total remaining would be 10, and we have to divide them in two teams. Two teams of 5 because Alice and Anne are there. So in this case, I have 10 players, and I want to put 5 of them in Alice's team and the remaining 5 in Anne's team. And as you can see, these labels are different, so this would give us the number. Label the teams as the name of the person, Alice or the Anne. So then that's the number of elements we have there. Then together what we have is probability of E, which is in the equiprobable sample spaces given by this formula, now is equal to n choose 10 choose 5, 5, and 12 choose 6, 6, but divided by 2 factorial, which is nothing but 2. This is divided in the numerator, so you can bring it up. 2 factorial is 2, and you write 10 choose 5, 5, and 12 choose 6, 6.